Today we'll be discussing on the topic about interpolation. Okay. So what is this topic? So say for example, you have these data points. Okay. This is y, this is x. Say for example, you have these 4 points. And you need the data somewhere here. Or you need, okay, so these are the corresponding x values, x1, x2, x3. So what if you need the data for the middle of 1 and 2, for example 1.5? So you do not have, or wala kay value ani sa y nimo because 4 man ang given. So what will you do is you will now interpolate, or you will do interpolation. So we will discuss different methods. So the first method that we will use to do interpolation is what we call Newton's divided difference. Interpolating polynomials. Taas kayo og name. Okay? So, how do we do this method? So, para magamit nato na nga method, sa ning eraser na. Eraser. And we'll concentrate only for 2 points. Okay? So, nakay 2 ka points karon. So, say for example nga mo ni ang graph. Muna ang graph sa imong data, pero wala kay name ani nga o wala kay equation ana nga function, wala kay equation. So imong buhaton, what will you do is you will connect, example, this is x1 and this is x2. What you will do is you connect these 2 points. Man. Wala kayo natunaw na. And then, so ang x1 nimo, you have, what is the y value for this? This is x sub 0 dai. 0, kita na to x sub 0, and kani nga value yung pangitao, no? So this will become f of x sub 0. And then this one is f of x1. Okay, f of x1. Okay, since we are just estimating this one, estimate rin ito na, no, kaning interpolation. So may tabuan instead nga kani ang graph nimo, imo siyang gi-approximate using this line. So may tabo, mo na ni karon ang value sa imong x. Call this one f1 of x. F sub 1. So, ang real niya nga value gid is kani diri. Kana dira, no? But since ato ra man yung gi-approximate using this method, kani may mo na ning error niya, no? May mo na ng error. So, based on this one, based on similar triangles sa makabuhat og nasa ni reason. Makabuhat og duha ka triangle ani. Kaning dako o kaning gamay nga triangle. So therefore, this becomes f1 of x minus kaning nga triangle first gamay f1 of x minus f of x sub o divided by x minus x sub o is equal to the larger triangle. So f of x1 minus f of o over x sub 1 minus x sub o. Okay? Or since we are targeting this value f1 of x, so ito yung i-rewrite. Ang left side is f1 of x. This becomes f of x sub o plus f of x1 f of x sub o x1 minus x sub o times x1 x minus x sub o. Okay? So, mo na ang value ni mo ron sa f1 of x. So, if you recall, ma-recall ninyo ang Taylor series expansion. So, kanisa nga forma is just the same sa Taylor series expansion. F of x is equal to f of x sub o minus plus f prime of x f prime of x times x minus sub o over 1 factorial. So, by the way, so kani nga term, kani siya is kuan na siya the approximation of the first derivative. Okay, anyway, focus on this one. What you will do is to get the intermediate value, this one, to get the intermediate value, you need 2 points, x sub o and x sub 1. So you get the y value for x sub o and the y value for x sub 1, and you can now get the value for the middle portion. So let's have an example on how to use linear interpolation. Okay, so we have a problem here. Estimate the natural logarithm of 2 using linear interpolation. First, perform the computation by interpolating between ln1 equals 0 and ln6 equals 1.7791759. Then, repeat the procedure but use a smaller interval from ln1 to ln4. Note that the true value of ln2 is 0.6931472. Okay, first is what is asked in the problem is we will determine the value of ln of 2. Okay, ln of 2. But we will use linear interpolation. So you have two values, you have ln1 and ln6. So obviously, this is not a linear data, no? But again, we can use linear interpolation to estimate the value of ln2. Okay. So our x sub o is 1 and x sub 1 is 6. So based on the equation, we'll just plug in the values in this equation. So f of x sub o, which is 1, is 0, plus f of x sub 1 minus f of x sub o over x sub 1 minus x sub o times x minus x sub o. So f1 of 2 is 0.3583519. So this is the value of ln2. Now, since we're given the true value, we can actually calculate the true error, which is 48.3%. So this is a very large error, almost 50%. So the next part is, what if we use smaller interval such as 1 and 4? So that would give you 0.464620981. So medyo duol-duol sa value nga 0.69. And this would give you the true error of 33.3%. Okay, so what you have noticed is, as you decrease the interval, the error also decreases. No? So since this is a logarithmic graph, so dili gina siya mo equal sa linear nga graph, but we can actually reduce the error by using smaller intervals of x sub o and x sub 1. Okay, so it is very straightforward. Now we will proceed with quadratic interpolation. So the first is linear. We approximate this curve with a line. Now we will use quadratic interpolation and see whether this would give a better result. Use quadratic interpolation. Okay. So for quadratic interpolation, we will estimate the graph using this equation. F sub 2 of x is equal to p sub 0 plus b1 x minus x sub o plus v sub 2 x minus x sub o times x minus x sub 1. Okay, so you're wondering why or where did we get this equation? Actually, this is just equivalent to this form: a sub o plus a1x plus a sub 2x squared. Okay, so this is the general second order polynomial representation. But we can also express this one into this form. They are just the same. Okay, so knowing that one, our objective now is to determine the coefficients of these three variables, okay, or the value of these three coefficients. So first, we'll do elimination process. Okay, so the first thing that we do is we substitute x to be x sub o. So what will happen is you have f sub f of, we just substitute x sub o for x. Okay, so this becomes f of xo is equal to b sub o. In this one, this becomes 0, also 0. Therefore, we now have this value. And then, after that one, let x be equal to x sub 1. Okay? So, this becomes f of x sub 1 is equal to bo, which is f of x sub o, plus b1 x sub 1 minus x sub o. And then get this one, this becomes 0 because of this term. So x1 minus x1 is 0. Therefore, to find out that b1 is f of x1 minus f of xo over 1 minus xo. And then last is let x be equal to x sub 2. So this becomes f of x sub 2 bo, which is f of x sub o, plus b1, which is now this value. So this becomes f of x1 minus xo times x2 minus x sub o plus b2 x2 minus xo x2 minus 1. And then transfer this one to the left side. This becomes b2 is equal to, and then divide by this term. This becomes f of x2 minus f of xo, and then divided by divided by x2 minus x1, right? f2 of b2 x2 minus x sub o. Okay, so with some algebraic manipulations, you will arrive at the value of this one. Okay, so let's apply this one from our previous example, and let's determine whether this would give much better result. Okay, so let's recall our x1 is, or rather x0 is 1, x1 is 4, and x2 is 6. So if you will apply quadratic interpolation, you need actually 3 points. Okay, so let's recall that f of x1 x of 0 is 0, ln which is ln of 1 is 1, ln of 4 is 1.386294, f of x2 is 1.791759. Okay, now b sub 0 is f of x sub 0, which is 0, and then b1 is this one, f of x1 minus f of xo, so you have 1.386294 minus 0 over 4 minus 1 is equal to 0.462 0981. Okay, and then B2, again we will plug in the values here. We'll arrive at a value of negative 0.0518731. Okay, and then after that one, we will substitute all these coefficients in the general formula. So you have f sub 2 of 2. Okay, meaning aning sub 2 dire, subscript 2 means second order interpolation or quadratic interpolation. You have p of 0, which is 0 plus b1, which is 0.4620981. 2 minus 1. 2 minus 1 is 1. Okay. Plus b2, which is negative 0.051731 times 2 minus 1, which is 1, times 2 minus 4, negative 2. Okay? Therefore, you'll arrive at a value of f sub 2 of 2, value of 0.565844. Again, the true value of ln of 2 is point ln of 2 is equal to 0.693147. So this gives true error of 18.4%. Okay, so this is a very good improvement from 33% using linear interpolation. Okay, so again, for the general rule, you can actually apply nth order polynomial. So you just follow this general formula. Okay. Now, if you will apply a third order interpolation, so madugangan na ni og b1 plus b2 plus b3 x minus x2 and so on. Okay, and then the next step is determine the value of these variables.